Namaste, welcome to mathematics class. Today we are going to start the chapter squares and square roots. The word square, you might have already heard it in the geometry part. Yes, square is a two-dimensional figure whose measure of four sides of a polygon are equal and each angle of a square is 90 degrees. And also we have come across in finding the area of square and also perimeter of square. We know the formula for the perimeter of a square is 4 into side and the area of square is S into S, that is area equal to S square. Here S stands for side of a square. Suppose if I know the side of a square is 3 units, then area of square becomes 3 into 3 equal to 9 units. So from this we can bring the definition of a square in arithmetic. That is, the square of a number is the product obtained by multiplying the number by itself. That is, 1 square equal to 1 into 1 equal to 1. 2 square is nothing but 2 into 2 equal to 4. 3 square equal to 3 into 3 equal to 9. 4 square equal to 4 into 4 equal to 16. 5 square equal to 5 into 5 equal to 25. 6 square equal to 6 into 6 equal to 36. 7 square equal to 7 into 7 equal to 49. 8 square equal to 8 into 8 equal to 64. 9 square equal to 9 into 9 equal to 81. 10 square equal to 10 into 10 equal to 100. So these are the square numbers of natural from 1 to 10. And these are the perfect square numbers. That is, these are square numbers and these are perfect squares. So I can see 36 is a perfect square of 6. 64 is a perfect square of 8. 16 is a perfect square of 4. 9 is a perfect square of 3. 100 is a perfect square of 10. So here a remember to be noted, that is, a given number is called a perfect square or a square number if it is the square of some natural number, and these numbers are exact squares and do not involve any decimals or fractions. Then how to find the square, whether it is a perfect square or not? Then the given number should be written as a product of its prime factors. If these factors exist in a pairs, then the number is a perfect square. Let me explain by taking one simple example. So here is the example. Is 256 is a perfect square. As I told you, to know whether it is a perfect square or not, we need to express the number as a product of prime factors. If these factors are in pairs, then the number is a perfect square. To know the prime factors, we'll go with the prime factorization which we learnt in class 6th standard. So 256. Since the number is ending with the digit 6, which is an even number, so I'll go with the even prime, that is 2. 2 ones 2. Then 2 twos 4. So 1 is remaining. Then 2 eights 16. Again the given number is ending with 8, which is an even. So we'll go with the 2. Then 2 6 12. 2 4s 8. Then again even number. So I'll go with the 2 table. 2 3s are 6. 2 2s are 4. Again even. So I'll go with the 2. 2 1s are 2. 2 6 are 12. Again 6 even number. 2 8s are 16. Again 8 even number. 2 4s are 8. Again even. So 2 2s are 4. Then 2 1s 2. So here 256 can be written as 2 into 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 2. That is 1, 2, 3, 4, 5, 6, 7, 8 times. 1, 2, 3, 4, 5, 6, 7, 8 times. Then you have to check whether they are in pairs or not. Yes, each factor is in a pair. Therefore, I can say 256 is a perfect square. Then this can also be written as 2 into 2 into 2 into 2 whole square. That is this 2 one time, these 2's one time, these 2's one time, and these 2 another time. So 4 times. 2 into 2 into 2 into 2 whole square. Then product of innards 2 2's 4, 4 2's 8, 8 2's 16. So 16 square is nothing but 256. So square of a number is 16 and its product is 256, which is called as a perfect square, and this is called as a square of a number. That is 16 square is 256. So here there are some facts about the perfect squares. Let us discuss one by one. So the first fact is a number ending with an odd number of zeros is never a perfect square. For example, 150. So in 150 there is only one zero, and 15,000 which consists of 3 zeros, 25,000 which consists of 3 zeros. So if the number is ending with the odd number of zeros, then those numbers are not a perfect squares, because you can observe here in 10 square is nothing but 10 into 10, 100 means even number of zeros. Suppose if the number is ending with even number of zeros, then there is a chance that the number can be a perfect square. But if the number is ending with odd number of zeros, without doing factorization, we can directly conclude that the number is not a perfect square. So now we'll go for second fact. Yes, squares of even number are always even. So squares of even numbers. So let us go here. There is a 2 square. 2 is a even number. Its square is 4. Then 4 is an even number. Then its square is 16. Then 6 square. 6 is an even number. 6 square is 36. 8 square. 8 is an even number. Its square is 64. 10 is an even number. Its square is 100. So here we can observe that the square of even number is always even. Not only from 1 to 10, even if you go for higher numbers like 12 square. 12 square is nothing but 144. Again 4 is ending, means it is an even number. If I go with 16 square is 256. You can observe in the example which I showed, 16 square is 256. Means 16 is an even number, and the square of even number, again I got the even number. Then think about square of odd number. You can observe here again the square of odd number. The square of odd number is always odd number. So squares of even number are always even. Similarly, squares of odd numbers are always odd. So 5 square, 5 is an odd. Its square is 25, which is also odd number. Now we'll go for fourth fact. Yes, the numbers ending with 2, 3, 7, 8 are not perfect squares. For example, 32 ending with the digit 2 means it is not a perfect square. 37 again ending with the digit 7, which is not a perfect square. 368 again ending with the digit 8, which is not a perfect square. So this states that if the digit is ending with 2378, then directly we can say that they are not a perfect squares. So if we go with the detail with the square numbers and their perfect square, 1 square is 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100. The square of a number having 1 in the units place, it's ending with the digit 1 in the perfect square. If a square number is 2, that is 2 square, its resulting answer is 4. Means the units place in the square number is 2. It's having the digit 4 in the perfect square. If I go with the 3 square, units place is 3, then its perfect square units place ends with the digit 9. 4 square, units place is 4 in the square number, then it ends with the digit 6 in the perfect square number. Then 25, having units place 5, it ends with the digit, perfect square ends with the digit 5. Then if I go with the 6 square, then it ends with the digit 6 in the perfect square. You can observe 4 in the units place of a square number or 6 in the units place of a square number, they both end with the digit 6 in their units place. Similarly, if I go with the ones in the units place in the square number, it ends with 1 in the perfect square number. Compare with the 7. 7 square means units place we have 7. Its perfect square is 49. 49 is a perfect square number. It ends with the digit 9. Then 1 with 9. You can compare with 9. 9 square. 9 square is nothing but 81. So here in the ones place we have 1. And here in the ones place we have 9. Both ends with the digit 1 in the units place in the perfect square number. Then if I go with the 8. 8 square is 64. Means units place in the square number is 8 and the perfect square unit place is 4. Similarly, you go with the 2 square. Units place is 2 and its perfect square units place is ending with 4. So if the perfect square is ending with the 4, then its a square number in the units place will be either 2 or 8. So 9 square equal to 81, right? Then the units, if the perfect square is ending with 1 in the units place, then its a square number in the units place will be either 1 or will be 9. So this is how you can see here 1, 2 is not there, 3 is not there, 4, ending with the 5, ending with 6, and 7 is not there, 8 is not there in the units place, and there is 9. So from here we can conclude that if the number, perfect number, square number is not ending with 2, 3, 7, 8, then there is a chance of square number, perfect square. If the number is ending with 2, 3, 7, 8, directly we can say they are not perfect squares. They are not perfect squares. So now we'll go with the next fact, fact number 5. The squares of a number other than 0 and 1 is either a multiple of 3 or exceeds the multiple of 3 by 1. So when we take a square number other than 0 and 1. So here let me take the example 3 square, which is nothing but 9. So 9 is exactly multiple of 3. Then 12 square is nothing but 144, which is exactly multiple of 3. Then if I go with 4 square equal to 16, where 16 is not multiple of 3, but 16 can be written as multiple of 3 plus 1, that is exceeds by 1. So 15 plus 1, we know that 3 5s are 15 and exceeds by 1 becomes 16. Then 13 square is nothing but 169. 169 can be written as 168 plus 1, where 168 is exactly multiple of 3. That is 56 3s are 168 plus 1. So exceeds by 1. Next, if I go with the next fact number 6. So this is also similar to the previous one. The square of a number other than 0 and 1 is either a multiple of 4 or exceeds a multiple of 4 by 1. For example, if I take 6 square equal to 36. So 36 is exactly multiple of 4. That is 4 9s are 36 or 9 4s are 36. 8 square is nothing but 64, which is also the multiple of 4, exactly multiple of 4. That is 16 4s are 64. Then 7 square equal to 49. 49 is not exactly multiple of 4, but here told that exceeds a multiple of 4 by 1. So 46 can be written as 48 plus 1, where 48 is exactly multiple of 4. That is 12 4s are 48 plus 1 is nothing but 49. 9 square equal to 81. 81 is not exactly multiple of 4, but 81 can be written as 80 plus 1, where 80 is exactly multiple of 4 plus 1. Next we'll go for next fact. The difference between the squares of two consecutive natural numbers is equal to their sum. The difference is nothing but subtraction between the squares of two consecutive natural numbers. Consecutive natural numbers are nothing but the continuous numbers. Suppose if I take the number 3, then the consecutive for the 3 can be preceding or can be succeeding. That is 3 consecutive is 4 or 3 consecutive is 2, like that. So 2 consecutive natural numbers is equal to their sum. For example, 4 square minus 3 square. So difference between squares of, you need to stress here the word squares of two consecutive natural numbers. So 4 is a natural number, 3 is a natural number, and these two are consecutive numbers with their respective squares. So 4 square minus 3 square can be written as 16 minus 3, 9, because 4 square is nothing but 16, that is 4 into 4 is 16. 3 square is nothing but 3 into 3, which is nothing but 9. 16 minus 9 is 7. But here the sentence said that the difference between the squares of two consecutive natural number is equal to their sum. So 4 square minus 3 square can be written as simply 4 plus 3, which is nothing but 7. Not only for 4 square and 3 square, for every two consecutive numbers square, their difference will be the addition of their base. That is 4 plus 3 equal to 7. If I go with the another example, so this is example 1. If I go with second example like 25 square minus 24 square. We know that 25 and 24 are two consecutive numbers and their square. Simply I can write 25 square is nothing but 625 minus 24 square is nothing but 576. The difference between is 49, or according to the statement, this statement, so 25 square minus 24 square is nothing but 25 plus 24, which is nothing but 49. Is it not simple? Yes, keep remember the difference between the squares of two consecutive natural numbers is equal to their sum. Sum in the sense addition of their bases. So, or in generally we can say that if n and n plus 1, n and n plus 1 be two consecutive numbers, then their difference becomes n plus 1 whole square minus n square is nothing but n plus 1, or simply remember that difference of two consecutive numbers is nothing but addition of their base or sum of their base. The square of a natural number n is equal to the sum of the first n not odd natural numbers. The square of a natural number n is equal to the sum of the first, sum in the sense addition, of the first n odd natural numbers. So we need to take the numbers, that to what kind of numbers? Odd natural numbers. How many odd natural numbers? What square number you are taking, there's n odd natural numbers you have to consider. So let me explain this by taking the example. So let me take 2 square. 2 square can be written as 1 plus 3 equal to 4. Is it not 2 square? Yes. How? He said that the square of n, the square of natural number n. What is the natural number here I have taken in place of n? I have taken 2. 2's square is nothing but sum of the first odd natural numbers. So first odd number is 1. Next odd number is 3. So 1 plus 3 equal to 4. So here base is 2. How many odd numbers I have taken? 2. So suppose if I go with 3 square. 3 square. So 1 plus, I have to take 3 odd numbers. That to what? First odd numbers from the first. So 1, 3 plus next odd number is 5. So which is nothing but 3 plus 5 is 8. 8 plus 1 is 9. We know that 3 square is equal to 9. So let me take another example like 5 square. 5 square is nothing but 5 I have taken, means 5 odd numbers I have to take. What kind of odd numbers? First odd numbers, that is 1 plus 3 plus 5 plus next odd number is 7 plus next odd number is 9. So how many odd numbers you have taken? 1, 2, 3, 4, 5. Now you sum up. 9 plus 1 is 10. Then 7 plus 3 is 10. 10 plus 10, 20. 20 plus 5, 25. Is it not 25 is nothing but 5 square? Yes. So keep remember, the square of natural number n is equal to the sum of first n odd natural number. We'll move to the next fact. That is fact number 9. So squares of natural numbers composed of only digit 1. So if the square number is only of digits 1, follow a peculiar pattern. What is that pattern? 1 square is nothing but 1. Then 1 square, that is 11 square is nothing but how many ones you are here? We have 2 ones. So the answer is 121. Next, 111 square is nothing but how many ones we have here? 3 ones. So 1, 2, 3 and write in the reverse order 2, 1. If we have 1 square, that is 1111. Then 1, 2, 3, 4. So there are 4 ones. So you have to write the natural numbers till 4. Then you go in reverse orders. That is 3, 2, 1. If you calculate 111 into 1111, the answer is 1, 2, 3, 4, 3, 2, 1. If I have 1 square, that is 11,111 square, since the ones are of 5 times, so I can write 1, 2, 3, 4, 5. Write in the reverse order 4, 3, 2, 1. So these all patterns are the tricks you need to remember, children. So 4, 3, 2, 1. Okay, these all patterns you have to remember so that it gets useful in this class or in the higher studies also. So we'll go for next fact. That is fact 10. We can also observe in the previous fact that the sum of digits of every such number is a perfect square. For example, 1. 1 is nothing but 1, which can be written as 1 square. In the previous 1, 2, 1, which is nothing but 11 square, right? So 1 plus 2 plus 1 is nothing but 4. You can add up 2 plus 1 plus 1 is nothing but 4. 4 is again a perfect square. Then 1, 2, 3, 2, 1, which is nothing but 111 square. 1, 2, 3, 2, 1, right? So if we sum up all this, 1 plus 2 plus 3 plus 2 plus 1 is nothing but 9. Again the resulting 9 is a perfect square, that is 3 square. Then 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1, that is 1111 square is 1, 2, 3, 4, 3, 2, 1. If we add up all those digits, then we'll get 16. 16 is nothing but again a perfect square, that is 4 square. 16 is a perfect square of 4, or 16 is equal to 4 square. So this is all about some facts. Now we'll go for next concept, children. That is some interesting patterns. Some interesting patterns. Adding triangular numbers. That is numbers whose dot patterns can be arranged as triangles. Dot patterns which can be arranged in the form of triangles are called as triangular numbers. So here you can observe triangular numbers are given 1, 3, 5, 10, means dots which can be arranged in the form of triangles are called as triangular numbers. So here 1 dot is considered which can be made a triangle, 3 dots with the triangle, then 5 dots with the triangle, not 5 dots, sorry, 6 dots which is in the form of triangles, and 10 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 dots in the form of triangles. And here combining two consecutive triangular numbers. So here you can observe 1 and 3. If I combined these two, I'll get in the form of square, right? That is 4 dots, which is in the form of square. So 1 plus 3 equal to 4, which is nothing but 2 square. 4 is a perfect square of 2. So 4 equal to 2 square. Again, if I combine with the 3 plus 6, that is these two triangular numbers, 3 plus 6, we get 9. 9 is a perfect square. So we can see the dots are arranged in the form of square. So 3 plus 6 equal to 9, which is nothing but 3 square. The same way 6 plus 10. 6 plus 10 is nothing but 16. 16 is nothing but 4 square, which can be arranged in the form of square. 4 dots vertical and 4 dots horizontal. So total number of dots are 16. So generally we say that 1, 3, 6, 10. 1, 3, 6, 10 are the triangular numbers. He will ask for 1 mark question, children. Write the triangular numbers. Then you have to write 1, 3, 6, 10 are the first 4 triangular numbers. So here observe the following pattern and fill in the blanks. So 1 plus 3 is nothing but 2. 4. 4 is nothing but 2 square. Or you can go in the previous concept what I explained, that is addition of odd numbers. There are 2 odd numbers. So 1 plus 3 equal to 4, nothing but 2 square. Or how many odd numbers you have used? It's a square. So here 3 odd numbers are used. So 3 square. Here 4 odd numbers are used. Therefore the answer is 4 square. Here 5 odd numbers are used. Therefore 5 square. Or you can add up all these things. So 9 plus 1 is 10, 7 plus 3 is 10 and 5. So 10 plus 10 plus 5 is 25 is nothing but 5 square. Or observe the number of odd numbers used. Starting n odd numbers, its square will become. So 1, 2, 3, 4, 5, 6 odd numbers. So 6 square. So the resulting answer, if you add up all this, you'll get 36. So 1, 2, 3, 4, 5, 6, 7 odd numbers. So 7 square. Hope this is clear for you. I'll go for the next pattern, children. So keep remember what are triangular numbers. 1, 3, 6, 10 are the triangular numbers. Note 1, 3, 6 and 10 are triangular numbers. Hope this is clear for you, children. So numbers between square numbers. numbers between square numbers. So observe the interesting pattern between two consecutive square numbers. So two consecutive square numbers again. So if I consider 3, its consecutive can be 4 or its consecutive can be 2 also. So I am taking 3 square and 4 square. We know that 3 square is nothing but 9, but that is 3 into 3 equal to 9. Then 4 square is nothing but 16. So if I write natural number from 9 to 16, 9, 10, 11, 12, 13, 14, 15, 16. We know that 9 and 16 are the perfect squares. Then what are these numbers are said to be? These numbers are said to be non-square numbers. Non-square numbers. Then how many non-square numbers can you find from 9 to 16? There are 6 non-square numbers. Right? From where to where? In between 9 and 16. Similarly, if I go with 1 square and 2 square. So 1 square is nothing but 1 and 2 square is nothing but 4. So if I write the natural numbers from 1 to 4, we get 1, 2, 3 and 4. We know that 1 and 4 are perfect squares because it has come from square numbers. And whereas these two are said to be non-square numbers, right? Then how many are they between 1 and 2? There are 2 non-square numbers. Right? So similarly, if I go with 2 square and 3 square, 2 square and 3 square. We know that 2 square is nothing but 2 2s are 4. Then 3 square is nothing but 3 3s are 9. So between 4 and 9, 4, 5, 6, 7, 8, 9. Whereas 4 and 9 are perfect square numbers, right? Then how many non-perfect square numbers you have? 4 non-perfect square numbers, right? So 4 non-square numbers. Now you can observe the following pattern. From 1 to 2, we have 2 non-square numbers. From 2 to 3, that is 2 square and 3 square, we have 4 non-square numbers. From 3 square to 4 square, we have 6 non-square numbers, right? So from this, we can observe that the non-square numbers are nothing but the multiple or in the form of multiple of 2's. Right? So from 1 to 2 we have 2 non-square numbers. From 2 to 3 we have 4 non-square numbers. From 3 to 4 we have 6 non-square numbers. So here we can write that the number of non-square numbers between the two consecutive numbers are in the pattern of 2n, where n is nothing but a smallest square number. So we can give the conclusion that there are 2n non-perfect square numbers between the squares of, keep remember it should be in the form of squares. So between the squares of the numbers whom, that is n and n plus 1. So keep remember n plus 1 square and n square, we have 2n, where 2n stands for non-perfect square numbers. So this is all about introduction of worksheet 1, children. So this is all about introduction of worksheet 1, and now we'll start worksheet 1 solving. Hope this is clear for you, children. Worksheet 1. Which of the following numbers are perfect squares? So we need to identify the perfect squares in the given numbers. 11, 16, 32, 36, 50, 64 and 75. So 11 is non-perfect square because it lies in 3 square and 4 square. We know that 3 square is 9 and 4 square is 16. So 11 is not a perfect square. Yes, 16 is a perfect square. Yes. So 16 is a perfect square. 32 no, because 6 square is 36 and previous 5 square is 24. So 32 comes in between 25 and 36. So it is not a perfect square. 36 is a perfect square. Yes. And 50 no, because odd number of zeros. As I told you, if it is a perfect square, it should have even number of zeros. 64, yes, 8 square is 64. 75 no, because 9 square is 81 and 8 square is 64. So 75 lies in between 8 square and 9 square. So keep remember, children, till natural number 1 to 30, the perfect square number should be known. Clear? Yes, we'll go for second question now. Which of the following numbers are perfect squares of even numbers? Means in the question he says that the given numbers are perfect squares, but in that we need to identify the perfect square of even numbers. So in the fact we have learnt that the square of even number are always even. The squares of even number are always even and the squares of odd numbers are always odd. So keeping this fact in our mind, we can directly identify which are perfect squares of even numbers. So 121 is the odd number, means it is a perfect square of odd number. 225, it is a perfect square, but it is the odd number, so it is the square of odd. 784, it is a perfect square. Since 784 is an even number, therefore this is a number of perfect square of even number. So I can guess. So first answer is 784. 784 is a even square. Then 841, odd number. Therefore it is a odd numbers square, that is square of odd number. Then 576, it is an even number, right? So it is a square of even. Then 6561, which is nothing but a odd number again. Therefore it is a square of odd number but not a even number. But in question he is asking square of even number. So we need to identify only the even numbers perfect square, because we know that square of even number is always even. So moving to third question. Which of the following numbers are perfect squares? So without calculating through factors, that is prime factors, we need to identify which of the following numbers are perfect squares by knowing the facts which we learnt, children. So first number is 100. You observe 100 consists of 2 zeros. That is even number of zeros, and 100 is a perfect square. Therefore 100 is a perfect square. Next is 2,05,000, which consists of 3 zeros, that is odd number of zeros. Therefore it cannot be a perfect square. Next 1, 2, 3, 4, 4 number of odd zeros. So there is a chance of to being a perfect square. Next 1, 2, 3, 4, 5. 5 odd numbers, odd number of zeros. Therefore cannot be a perfect square. So from the number of knowing odd number of zeros and even number of zeros, we can say whether it is a perfect square or not. Fourth question. By just observing the digits at one's place, tell which of the following can be perfect squares. Just observing the digit in the ones place, we need to say whether it can be a perfect square. Yes. So we know that if the digit end with the numbers 2, 3, 7, 8, 2, 3, 7, 8 in the ones place, they cannot be a perfect squares, or odd number of zeros cannot be a perfect squares. So 1026, yes, the digit in the ones place is 6, so chance of being a perfect square. 1022, so ending with the 2 cannot be. 1024, so end with the digit 4, so there is a chance of being a perfect square. Next 1027, 7 in the digit units place, so cannot be a perfect square. Now we'll go for fifth question, children. Next, how many non-square numbers lie between the following pairs of numbers? So we need to identify the number of non-square numbers lie between the pair of numbers. So here the numbers given are 7 square and 8 square. So we know that 7 and 8 are consecutive numbers and they square. So based on the fact that is to find the number of non-square numbers, we have a formula called as n and n square and n plus 1 whole square, which is nothing but 2n. That is 2 into n gives a number of non-square numbers. So 2 into, and n is nothing but the smallest number between 7 and 8 is 7. So 2 into 7 equal to 14 non-square numbers between 7 square and 8 square. So similarly we need to solve the second question also, that is 10 square and 11 square. So n square and n plus 1 whole square is nothing but 2n. That is 2 into 10 equal to 20 non-square numbers. Third question, 40 square and 41 square. So n square and n plus 1 whole square is nothing but 2 into n, that is 2 into 40 equal to 80 non-square numbers. Then fourth question, 80 square and 81 square. So 80 is nothing but n square and 81 is nothing but 80 plus 1, that is n plus 1 whole square is nothing but 2n, that is 2 into smaller number n is nothing but 80. So 2 into 80, 160 non-square numbers. Next, fifth one, 101 square and 102 square. So n square and n plus 1 square equal to 2n. So 2 into 101 is nothing but 202 non-square numbers. Next, sixth one, 205 square and 206 square. That is n square and n plus 1 square is nothing but 2n, that is 2 into 205 equal to 2 5s 10, 2 zeros are 0 plus 1 1, 2 2s are 4, that is 410 non-square numbers. Hope this is clear for you, children. I'll go for next main now. So write down the correct number in the box. So here 100 square minus 99 square, it's nothing but the difference of square of two consecutive numbers. So we know that difference of square of two consecutive numbers is nothing but the addition of the base. Whereas here finding the number of non-square numbers. To find the non-square numbers we have the formula 2n, where n stands for square of smaller number, only smaller number. No, you should not consider the square. Only before coming to the square, what we have the base, that base we need to consider, that is 2 into 205 equal to 410. Whereas here he is asking difference between the two consecutive square numbers. So 100 square minus 99 square is nothing but 100. We have learnt the difference of two consecutive square numbers is nothing but the sum of the numbers, that is 100 plus 99 is nothing but 199. The same way 27 square minus 26 square is nothing but 27 plus 26 is nothing but 6 plus 7 is 13. So 2 plus 2, 4 plus 1, 5. That is 53. The same way 569 square plus 568 square is nothing but 569 plus 568. 8 plus 9 is 17. Then 6, 12, 13. Then 5, 10, 11. So 1137 is the answer. Keep remember children, don't get confused. This is also square of consecutive numbers. This is also square of consecutive numbers only. But here he is asking non-square numbers and here he is asking the difference. So the difference you need to add up the base. To find the non-square numbers you have to use the formula 2n. Clear? Seventh main. Observe the pattern in the following and find the missing numbers. So we need to observe these two patterns and we need to fill the remaining blanks. So 121. So here underline is given for 2. Therefore 2 digits, that is 2 is repeating 2 times, that is 22 square. And down we have addition of all these numbers, that is 1 plus 2 plus 1. Similarly, in the next one, 1, 2, 3, 2, 1 and the dash is given for 3 here. So 3 is repeating 3 times, therefore, and it's a square, and down you can see the addition of numbers, that is 1 plus 2 plus 3 plus 2 plus 1. Same way here, 1, 2, 3, 4, 3, 2, 1 and the dash is given for 4. So 4 should be repeated 4 times with the square. And down we need to add up all the numbers, 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1. Same way here, and the dash is given for 5. So 5 should be repeated 5 times to the power of 2. Then 1 plus 2 plus 3 plus 4 plus 5 plus 4 plus 3 plus 2 plus 1. And the next one, dash is given for 6. Therefore 6 should be repeated 6 times. 3, 6, 6, 6, 6, 6, 6 whole square. Then 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. That's all children. We have to see the above pattern and write the remaining pattern, missing pattern. Okay, now we'll move to 8th main. Which of the following triplets are Pythagorean? So we need to identify whether they are triplets of Pythagorean or not. So in the class 7th we have learned that hypotenuse is the longest side, right? So I'll consider first triplets and check whether they are Pythagorean or not. Among these 3 numbers, which is the highest digit? 5. 5 is the highest digit, that is hypotenuse square equal to base square plus perpendicular square. 5 square is 25, 4 square is 16 plus 3 square is 9. So 25 equal to 16 plus 9 is 25. So LHS equal to RHS. So this satisfies the Pythagorean. Therefore 3, 4, 5 is a triplet of Pythagorean. So similarly we have to check for next. So I'll go for next 6, 7, 8. Among this 8 is the highest. So 8 square equal to 6 square plus 7 square. 8 square is 64. 6 square 36 and 7 square 49. Then 64 equal to 9 plus 6 is 15. 4 plus 4 is 8. So I can say that 64 is not equal to 85. Therefore 6, 7, 8 are not triplets of Pythagorean. So now I'll move for third one, that is 10, 24, 26. So among this 26 is the highest. So 26 square equal to 24 square plus 10 square. 26 square, that is 26 into 26 is nothing but 676, equal to 24 into 24 is nothing but 576, and 10 square, 10 into 10 is nothing but 100. So 676 equal to 100 plus 576 is 676, satisfies. Therefore 10, 24, 26 are triplets of Pythagorean. Now I'll move to the fourth question. Fourth question is 2, 3, 4. 2, 3, 4. Among this the highest is 4. So 4 square equal to 2 square plus 3 square. 16 equal to 2 square is 4 and 3 square, 3 into 3, that is 9. Then 16 equal to 9 plus 4 is 13. So not equal. Therefore I can say 2, 3, 4 is not a triplets of Pythagorean. So here there is another method of solving whether they are Pythagorean triplet or not. Okay, let me show that also. That is, if A, B, C are three natural numbers with A as the smallest of them. So among these A, B, C, if I consider A is the smallest number, then if A is odd, that is the smallest number is odd, then sum of other two numbers is A square, that is B plus C equal to A square. And the difference is, that is B square minus C square is 1. If A is even, in case if in the smallest number, if it is not odd, if it is an even number, then sum of other two numbers is A square by 2 and the difference is 2. So let me explain this by taking the examples. So if I take 3, 4 and 5, among these two the smallest number is 3, that is A equal to 3. If I take, we know that 3 is an odd number. So for the odd number the condition states that if A is odd, then sum of two numbers, that is B plus C, sum of two numbers is A square. A square is nothing but 3 square. What is 3 square? 3 square is 9. And if and the difference becomes, and the difference is said that the difference of two numbers is 1. So we need to select the two numbers in such a way that the addition of two numbers is 4 and the difference of the same two numbers is 1. So if I go with 9 plus 1 is 10, 10 by 2 is 5. So if I go with 5 and 4, 5 and 4 you can check. 5 plus 4 equal to 9 and 5 minus 4 equal to 1. So this satisfies the addition of two numbers and the subtraction of two numbers. Therefore, along with the 3, the other two numbers are 5 and 4. This is how we need to find the given number. Clear? So if I go with the other number, let me take So let me take other example 10, 24, 26. So among these three the smallest number is 10. So A equal to 10, which is nothing but even number. In the even, the other two numbers, that is addition of two numbers, is A square by 2. That is 10 square by 2 equal to 100 by 2 equal to 50. And the subtraction of two numbers must be equal to 2. Then 50 plus 2 is 52. Then 52 by 2 is nothing but 26. Right? Because it should be shared for B plus C and B minus C. So we have to divide 52 by 2 equal to 26. Then 26 plus 2, if I go 28. 28 plus 26, it will cross more than 50. So I'll go for subtraction. 26 minus 2 is nothing but 24. So 26 plus 24 is equal to 50, which satisfies the addition. The same way for odd number, if it is, then B plus C is 3 square. That is A square. A square is nothing but 3 square, nothing but 9. Then subtraction of two numbers, that is B minus C equal to 1. Then 9 plus 1 is 10. So 10 by 2 is 5. So 5 plus 1, if I go, you will get 6. Then 5 plus 6 becomes 11. But I required is 9. So 5 minus 1 equal to 4. Then 5 minus 4 equal to 1. Then 5 plus 4 equal to 9, which satisfies. Therefore, if 3 is the one number, the other two numbers becomes 5 and 4. So 3, 4, 5 are the Pythagorean triplets. The same way here for even number. A square by 2, 100 by 2, 50. Then B minus 2, C equal to 2. Then 50 plus 2 is 52. 52 by 2 is 26. So 26, if I go for addition here, it becomes 28. 28 plus 26, it becomes greater than 50. So 26 minus 2, if I go, I'll get 24. 26 minus 24 equal to 2, and 26 plus 24 equal to 50, which satisfies addition and subtraction of numbers. This is how we need to find if one digit is given or asked you to find the Pythagorean triplet or not. Either you can go with the previous method which I have shown, or you can follow this method also, children. Thank you. Have a nice day, children.